It is a freezing cold winter morning. You turn the ignition key expecting your car to roar to life and warm up, but instead the engine stumbles terribly, idles incredibly rough, and might even stall outright in your driveway. That highly frustrating situation is a classic symptom of code P050B, which tells you that the powertrain control module has detected a serious malfunction with the cold start ignition timing performance. When an engine has been sitting overnight in freezing temperatures, the thick metal block absorbs all the ambient heat, making it incredibly difficult for the fuel to atomize and ignite properly. To compensate for this, your engine computer is programmed to automatically advance the ignition timing, firing the spark plugs slightly earlier in the combustion cycle to guarantee a smooth idle. While the cold cylinders warm up, the computer relies heavily on a perfectly synchronized dance between the crankshaft position sensor, the camshaft position sensor, and the engine coolant temperature sensor to calculate this exact timing strategy. If the computer suddenly realizes it cannot precisely control or verify the ignition timing during a cold start, it throws this code to warn you before raw fuel starts dumping into the exhaust and completely melts your expensive catalytic converter. Your first diagnostic step is to look for any massive vacuum leaks around the intake manifold, because unmetered air entering a cold engine will completely ruin the air-to-fuel ratio and force the timing parameters entirely out of bounds. If the rubber hoses look pristine, you will need a diagnostic oscilloscope to properly test the crankshaft and camshaft sensors. You want to tap into the signal wires and look for a beautifully clean, square wave pattern on the screen while the engine is running. If you see any erratic voltage spikes or sudden drop-offs in the pattern, you have found a failing magnetic sensor or a heavily corroded electrical connection that is sending a garbled signal to the main computer. Always fix any other active sensor codes first, because a lying engine temperature sensor can easily trick the computer into setting a completely false timing code, sending you on a wild goose chase for a mechanical problem that does not actually exist.